Can information about the past give us clues about what will happen in the future? It certainly can. In this video, we will learn how to make predictions using something called experimental probabilities. This video will guide you step by step on how to find experimental probability and how we can apply it to predict the outcome of a future event. Let's start things off by looking at an example. Let's say that you run a diner that sells cheeseburgers and hamburgers. Of the 12 burgers sold yesterday, 4 were cheeseburgers. Using this information, let's predict how many cheeseburgers we would sell if we sell 6 total burgers today. The first step in our prediction is to find the experimental probability. This is the probability based on what we learned in the past. We'll define experimental probability as the number of times an event occurred divided by the total number of trials. In our example, the total number of trials is the total number of burgers sold, and the event that we are interested in is the number of cheeseburgers sold. We know that out of the 12 burgers sold, 4 were cheeseburgers. So the probability of selling a cheeseburger is 4 over 12, which can be simplified to 1/3. Now, we know that in the past, the probability of selling a cheeseburger was 1/3 or 1 in 3. And we can guess that probability will be about the same in the future. So we can use it to make a prediction. Knowing that our ratio of cheeseburgers to burgers is given by 1/3, what would our ratio look like if we sold 6 burgers? This can be written as n over 6, where n is the number of cheeseburgers we expect to sell of the next 6 burgers sold. Setting our experimental probability equal to our expected ratio of n over 6, we can solve for n to find how many of the next 6 burgers we sell will be cheeseburgers. Okay, in order to solve for n, we need to do a little bit of thinking. How do we get from our fraction of 1/3 to a fraction with a denominator of 6? Well, notice that you can multiply the denominator of 1/3 by 2 to get a denominator of 6. That means we should multiply the numerator by 2 to get n. Multiplying the numerator by 2, we know n equals 1 times 2, which is just 2. And that's our answer. Of the next 6 burgers we sell, we expect 2 of them to be cheeseburgers. Using the same method, let's try another one. Boats dock at a busy marina. Of the first 10 boats to dock at the marina one day, 6 were blue boats. Considering this information, how many of the next 20 boats should you expect to be blue? To solve this problem, let's first find our experimental probability. Remember, the experimental probability is given by the number of times an event occurred over the total number of trials. In our case, this gives us 6 blue boats over 10 total boats that docked at the marina, which can be simplified to 3/5. So, in the past, 3 out of 5 boats were blue, and we can guess that will be the same in the future. To make our prediction, let's define our second ratio as the number of blue boats expected to dock at the marina of the next 20 boats. That gives us n over 20. Setting that ratio equal to 3/5, we can now solve for n. Again, because we want our two fractions to equal each other, we have to think, how do we get from the denominator of 5 to a denominator of 20? In order to get from 5 to 20, we have to multiply by 4. And if we multiply the denominator by 4, we also want to multiply the numerator by 4 to get an equivalent fraction. Multiplying 3 times 4, we get 12. 3/5 is equal to 12 over 20, which means that n is equal to 12. Of the next 20 boats to dock at the marina, we expect 12 of them to be blue. Alright, moving on to our third example now, let's take a look. Think about your favorite basketball team. Of its past 35 games, your favorite team has won 15 of them. Using this information, how many more games do you predict the team will win if there are 21 games left in the season? Let's answer this question using the same method we've used so far. The first step is to find the experimental probability, which is given by the ratio of the number of times an event occurred over the total number of trials. The total number of trials is the number of games the team has played so far. So our denominator will be 35. And the number of times an event occurs in our case is the number of wins the team had. So we'll put 15 in the numerator. That gives us an experimental probability of 15 over 35, which can be simplified to 3 over 7. We can set 3 over 7 equal to n over 21, which depicts the number of games we expect to win if we play 21 games. Now let's solve for n. To find n, we want to get our fraction of 3 over 7 to have a denominator of 21. To get from 7 to 21, we have to multiply by 3. That means we should multiply the numerator by 3 as well. This gives us our n, which is equal to 9. Of the next 21 games, you expect the team to win 9 of those games. Alright, now we'll take a look at one last example to finish things off. Let's go back to the diner example we saw in our first problem. In your diner, you also sell some delicious sides: onion rings, garlic fries, and coleslaw. In the past week, your shop sold 19 sides of onion rings, 36 sides of garlic fries, and 21 sides of coleslaw. Using this information, how many of the next 57 sides sold should you expect to be garlic fries? As we've been doing so far, let's start by finding our experimental probability. Remember, the experimental probability is the ratio given by the number of times an event occurred divided by the total number of trials. In our example, the event we are interested in is the number of garlic fries sold. So we'll put 36 in our numerator. Now, what is the total number of trials? Well, the total number of trials is going to be the total number of sides we sold, which can be found by adding up all the sides sold during the past week. This gives us 19 plus 36 plus 21, which is 76. So our experimental probability will be 36 over 76, which can be simplified to 9 over 19. Now we'll set our experimental probability equal to the ratio of garlic fries we expect to sell of the next 57 sides sold. We can represent this ratio as n over 57. Now our equation reads 9 over 19 equals n over 57. Let's solve for n now. To get from a denominator of 19 to a denominator of 57, we have to multiply by 3. When we multiply the denominator by 3, we also want to multiply the numerator by 3. That gives us a fraction of 27 over 57. And we've found that n equals 27. So, of the next 57 sides sold, we expect 27 to be garlic fries. Awesome! And that's it for this lesson. Now you know how to use experimental probabilities to make reasonable predictions about the future. Congratulations!